Okay, so I wanted to do another slide on explaining the anode angle and how that would affect both anode Heal effect and receptor exposure. So if you're still confused about anode Heal effect, I do have another video on that one. You can go back to that. But in general, we know that the beam coming out of the X-ray is more intense on the cathode side than the anode side. Why? Because the anode is on this side, it's at an angle, and some of the intensity gets lost at the heel, or this little corner here. I think this is sometimes difficult because as technologists, I don't physically change, I don't open my tube and change the degree of angle, right? It happens inside the tube and you don't see it and you don't move it. So when you change your settings, depending usually on small focal spot or large, we'll adjust the degree of anode angle. So decreased anode angle, which is this one, say 12, or it might say 6, means your anode is steeper up and down. Increased anode angle means this heel kind of gets pushed back. So it would be more like this picture here with the 24, where it's the angle is kicked back and this heel is further back, right? When we decrease anode angle, so the smaller one, we decrease effective focal spot size, but we also increase anode Heal effect because this heel is now way more in the way. So if you go, let's see, go down to this one where I have the purple arrow, this heel is stealing quite a bit. Whenever we have an increase in Heal effect, we have a decrease in receptor exposure because part of that beam is decreased in intensity. When you increase anode angle, so this 24 one, the heel kicks back, it steals less, so you have a decreased anode Heal effect, and you would have an increased receptor exposure. I hope that makes sense. And then these two pictures were just about patient size and collimation, right? So your asthenic patient, your thin, slender patient, more of that beam is going to pass through to your receptor. Your hypersthenic or larger patient that has more body mass is going to absorb more. So less X-ray photons are going to make it through. Collimation, field of view, don't get tripped up by those terms, okay? Increased collimation, smaller. Increased beam restriction, also smaller. Increased field of view, wider. Okay? Anytime you have a bigger field or decreased collimation, you're going to have an increase in your receptor exposure because more reach to your receptor. Okay. All right, the other two terms that I think can kind of coincide with receptor exposure would be when we talk about underexposure or overexposure. So underexposure means not enough of your X-ray photons, A, made it through the patient, or B, reached your image receptor. It's usually associated with quantum model or image noise, or they say your image is grainy in appearance or kind of sandy, right? Most often, it's because you didn't use enough mass, because our KVPs are pretty much that, but if you really use the wrong KVP, and you're way too low, you use 50 and you're supposed to be at 80, then definitely that would come into play. The majority of the time, our MAS is really our main factor here for quantum model, but not enough X-ray photons here. Okay, your exposure index number or your EI number would be low. If you're using CR, that S number, remember, is inverse, a little bit backwards. And overexposure is when too many X-ray photons reach the image receptor. We'll use image saturation. You saturated that patient or that receptor with too many photons. What happens often is that the soft tissue, say around this hand, we're going to lose the detail of the soft tissue. So ideally we see some soft tissue around the fingers. The overexposed one is burnt out. It has, kind of dark, or we lose some data from that. Usually that is because the mass is set too high It could be KBP if you're really in the wrong spot, but your mass is too high. If you're using digital, your EI number will be high, and then CR is that inverse and it'll be backwards. So under overexposure, model and noise, saturation. Okay. So just, a little roundup here for receptor exposure. We know our primary controller is mass. KBP, remember KBP is really going to come into play with the 15% rule here. We could be asked about how our SID, increasing or decreasing SID. And just remember those, right? Increasing SID is farther away, decreasing closer. Grids are going to absorb part of that beam for us. So they're a little bit of a blocker, or sometimes I call them a bouncer. They take care of the riffraff. So anything that's going to remove part of your beam and make it less in numbers will decrease your receptor exposure. Okay. Patient size, pathology could also come into play. Contrast. Watch the wording on the contrast questions. Is it asking me digital contrast? Well, they're going to be your lookup table, bit depth, quantization, those ones. DQE is how contrast is evaluated, remember, through the SNR. Post-processing controller of contrast is window width. Remember, window level is brightness. It could be asking me about equipment, my KBP setting, low contrast, high contrast, grids, OID, filtration, collimation. And then it could be asking me about how patient size, density, pathology, contrast media have an effect on my subject contrast. So just watch the terminologies, and because I think that's important when reading your question, make sure you know what it's asking you and look for those keywords. Okay, so these really took us through contrast and receptor exposure, parts of the imaging chart on the specs, and just remember contrast is still on there even though it's out of the chart. Okay, good luck.